Let's explore the architecture of online multiplayer gaming systems. We will delve into the key components and strategies that make these immersive experiences possible. The architecture consists of two primary components: the game client and the game server. The game client is the player's interface, managing local game state and user input. The game server serves as the central authority, responsible for game logic and synchronizing the state among all players. Communication between the client and server is crucial for real-time interaction. This communication relies on various protocols such as TCP, Transmission Control Protocol or UDP, User Datagram Protocol, WebSockets, and Hypertext Transfer Protocol or Hypertext Transfer Protocol Secure. There are generally two types of game server architectures. First, the authoritative server, which maintains a single source of truth for the entire game state. Second, the peer-to-peer architecture, where players communicate directly with one another. To maintain a consistent game world, state synchronization is essential. Snapshot updates involve sending the complete game state at regular intervals. Delta updates, on the other hand, transmit only the changes from the previous state, which optimizes bandwidth usage. Latency or network delay can significantly impact gameplay. To mitigate this, client-side prediction is often employed. This involves predicting player movements locally and immediately, while sending the input to the server for validation. Here is an example. First, a function named predictMovement is defined. It takes two arguments, player and input data. Then we apply movement immediately. The player's position is updated by adding the input data's velocity. After that, the information is sent to the server for validation, and lastly, the function returns the player's position. To handle a large number of players, load balancing is crucial. Geographic distribution involves routing players to the nearest server regions to minimize latency. Dynamic scaling automatically adjusts the number of servers based on player demand, ensuring optimal performance. Maintaining fair gameplay requires robust anti-cheat systems. Server-side validation is one technique where the server verifies player actions and rejects any invalid movements or actions. Here is an example. First, a function named validateMovement is defined. It takes two arguments, player and new position. Then the maximum speed and distance are calculated, after which if the distance is greater than the maximum speed, then the function returns false, rejecting the invalid movement. Otherwise, it returns true. Data persistence is necessary for storing player progress and game state. This involves storing player data such as profiles, progress, and achievements, as well as persisting the world state and match history. As the game grows, scalability becomes increasingly important. Horizontal scaling involves adding more server instances to handle the increased load. Microservices architecture splits the system into independent services, which allows for independent scaling and easier maintenance. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.